Right, now we're learning about paths. Um, to show Rust where to find an item in a module tree, we use a path in the same way you would use a path when navigating a file system. To call a function, we need to know its path. Path can take two forms, an absolute path and a relative path. Okay, this is just like paths in a file system, indeed. Absolute path is the full path starting from a crate root. For code from an external crate, the absolute path begins with the crate name, and for code from the current crate, it starts with the literal crate. Okay. A relative path starts from the current module and uses self, super, or an identifier in the current module. Both absolute and relative paths are followed by one or more identifiers, separated by double colons. Returning to listing 7-1, say we want to call the add to waitlist function. So that. This is the same as asking what's the path of the add to waitlist function. It's right here. Right, crate, and then front of house, and then hosting, and then add to waitlist. Listing 7-3 contains listing 7-1 with some of the modules and functions removed. Okay. We'll show two ways to call the add to waitlist function from a new function, eat at restaurant. Right, that one. Let me type that. Function eat at rest. The absolute path would be crate, front of house, hosting, and then add to waitlist. This is the absolute, and the relative path would be, because it's the same file, I think, you can just do front of house, and then hosting, and add to waitlist. Because both this function and that function are in the same file here. This is the relative path. Well, if we had this function in some other path, maybe other module, another file, then this might be different, maybe. I don't know. These paths are correct, but there's another problem remaining that will prevent this example from compiling as is. We'll explain why in a bit. Okay. The eat at restaurant function as part of our library creates public API. So we mark it with the pub keyword. Oh, I didn't do that. So let's do pub. In the exposing paths with the pub keyword section, we'll go into more detail about pub. The first time we call the add to waitlist function in the eat at restaurant, we use an absolute path. So this is the absolute path starting from crate. This crate. So crate means this crate. The add to waitlist function is defined in the same crate as eat at restaurant, which means we can use the crate keyword to start an absolute path. We then include each of the successive modules until we make our way to add to waitlist. You can imagine a file system with the same structure. We'd specify the path to run the add to waitlist program, right? Using the crate name to start from the crate root is like using / to start from the file system root in your shell. Well, in Windows, it would be like D. So that it would be the root, actually. But this is probably for Unix-like systems. The second time we call add to waitlist in eat at restaurant, we use the relative path. The path starts with front of house, the name of the module defined at the same level of the module tree as eat at restaurant. Right. So this is at the same level as Eat at Restaurant. Here the file system equivalent would be using the path, front of house, hosting, at waitlist. Starting with a module name means that the path is relative. Okay, yeah, there's no forward slash at the beginning there. So that's the difference. Choosing whether to use a relative or absolute path is a decision you'll make based on your project, and depends on whether you're more likely to move item definition code separately from or together with the code that uses the item. For example, if we move the front of house module and the eat at restaurant function into a module named customer experience, well, move the front of house module and eat at restaurant function to customer experience module. We need to update the absolute path to add to waitlist, but the relative path would still be valid, right? If you keep these at the same level, both this function and this module. However, if we move the eat at restaurant function separately into a module named dining, the absolute path to the add to waitlist call would stay the same, but the relative path would need to be updated. Our preference in general is to specify absolute paths because it's more likely we'll want to move code definitions and item calls independently of each other. So the preference in general is to specify absolute paths, not relative. Got it. Let's try to compile. Okay. No. So let's get into restaurant and then cargo run. The bin target must be available. Cargo. It isn't? Oh. Cargo build then. So you can't just cargo run a library, obviously. Okay. You can build it. Add to waitlist is not publicly re-exported. Private module. Module hosting is defined here. Module hosting is private. Publicly re-exported. Okay. The error messages say that the module hosting is private. Let's have a look. Hosting, right, it's private. That's right. In other words, we have to correct paths for the hosting module and the add to waitlist function, but Rust won't let us use them. We have the correct paths, right? But Rust won't let us use them because it doesn't have access to private sections. In Rust, all items are private to parent modules by default. If you want to make an item like a function or struct private, put it in a module. Okay, so in Rust, all items, all functions, methods, structs, enums, modules, and constants are private to parent modules by default. If you want to make an item like a function or struct private, you put it in a module. This is interesting. So functions and so on that are not inside a module by this logic are public. Items in a parent module can't use the private items inside child modules, but items in child modules can use the items in their ancestor modules. This is because child modules wrap and hide their implementation details, but the child modules can see the context in which they're defined. To continue with our metaphor, think of the privacy rules as being like the back office of a restaurant. What goes in there is private to restaurant customers, but office managers can see and do everything in the restaurant they operate. Rust chose to have the module system function this way so that hiding inner implementation details is the default. That way you know which parts of the inner code you can change without breaking outer code. However, Rust does give you the option to expose inner parts of child modules code to outer ancestor modules by using the pub keyword to make an item public. Let's return to the error that told us the hosting module is private. We want the eat@restaurant function in the parent module to have access to the add-to-waitlist function in the child module. So we mark the hosting module with the pub keyword as shown in listing 7-5. So like this. So we can just do pub here. Pub node hosting. Unfortunately, the code in listing 7-5 still results in an error. Cargo belt. And the function itself is private. What happened? Adding the pub keyword in front of mod hosting makes the module public. With this change, if we access front of house, we can access hosting. But the contents of hosting are still private. Making the module public doesn't make its contents public. The pub keyword on a module only lets code in its ancestor modules refer to it. Okay. Not access its inner code. Okay, so it's not very useful to have this pub here then. Is this level where eat@restaurant is that considered a parent module of hosting, I wonder? Because modules are containers, there's not much we can do by only making the module public. We need to go further and choose to make one or more of the items within the module public as well. The errors in listing 7-6 say that the add-to-waitlist function is private. The privacy rules apply to structs, enums, functions, and methods, as well as modules. Structs, enums, functions, and methods, as well as modules. Okay. Let's also make the add-to-waitlist function public by adding the pub keyword. Okay. Pub function. There we go. Now the code will compile. Okay, let's try that. Cargo build. All right, it compiled. Now cargo run. There is no bin target. Where did you build it then? Target, debug. Is it here? Build? No. Okay, it compiled, but can't actually run it. To see why adding the pub keyword lets us use these paths, I'm wondering what happens if I remove this pub here. Let's try and build that as well. Right, private module. So you have to make this public as well in order to access its public function. Okay, so this is not useless in that case, or this example either. In order to access a public interface or a public function of a module, you need to make that module public as well. It's good to know. In the absolute path, we start with crate, the root of our crates module tree. The front of house module is defined in the crate root. Yeah, while front of house isn't public, because the eat@restaurant function is defined in the same module as front of house. So this is defined at the same level. This has the same level as front of house. We can refer to front of house from eat@restaurant. So siblings can refer to each other. Siblings can refer to each other without having the sibling be public explicitly. Next is the hosting module marked with pub. We can access the parent module of hosting, so we can access hosting. Right. We made it public. Finally, the add to waitlist function is marked with pub, and we can access parent module, so this function call works. So to access a public function buried deep inside submodules like this, every module, every submodule, or every parent module that contains this public function needs to be public as well. Public or at the same level as the calling code. So public or sibling. In the relative path, the logic is the same as the absolute path, except for the first step. Rather than starting from the crate root, the path starts from front of house. Yeah. The front of house module is defined within the same module as eat at restaurant, so the relative path starting from the module in which eat at restaurant is defined works. Then, because hosting and add to waitlist are marked with pub, the rest of the path works, and this function call is valid. Right. They are the same thing anyway. One is absolute, the other is relative. If you plan on sharing your library crate so other projects can use your code, your public API is your contract with users of your crate that determines how they can interact with your code. There are many considerations around managing changes to your public API to make it easier for people to depend on your crate. These considerations are out of scope of this book. If you're interested in this topic, see Rust API guidelines. Okay. Let's read through it here as well. Best practices for packages with a binary and a library. We mentioned a package can contain both a main RS binary crate root as well as a library crate root, librs. And both crates will have the package name by default. Typically, packages with this pattern of containing both a library and a binary crate will have just enough code in the binary crate to start an executable that calls code with the library crate. This lets other projects benefit from the most functionality that the package provides because the library crate's code can be shared. I don't get it. What does this mean? We'll have just enough code in the binary crate to start an executable that calls code with the library crate. The module tree should be defined in source lib.rs. Then any public items can be used in the binary crate by starting paths with the name of the package. Any public items can be used in the binary crate by starting paths with the name of the package. Right, okay. The binary crate becomes a user of the library crate, just like a completely external crate would use the library crate. Module tree should be defined in lib.rs. Module tree should be defined here. What does that mean? Yes, I would need to look at example library crates to understand what they're talking about here. Why don't they have examples? Like an example here would be nice. Do they mean all library crates have modules like this? This helps you design a good API. Not only are you the author, you're also a client. Right. Okay, so you should be the first user of your library, basically, and have both a main.rs binary crate and lib.rs library crate root. In Chapter 12, we'll demonstrate this organizational practice with a command line program that will contain both a binary crate and a library crate. Okay, great. So they will have an example later on. Starting relative paths with super. We can construct relative paths that begin in the parent module. rather than the current module or the create root by using super at the start of the path. This is like starting a file stem path with, okay, double period syntax using super. So this just goes back a level. For instance, and if you've never seen this before, when you do call directory double dot in DOS, will go back one level to previous folder on Windows. Again, like this. So that's what super does. Using super allows us to reference an item that we know is in the parent module, which can make rearranging the module tree easier when the module is closely related to the parent. But the parent might be moved elsewhere in the module tree someday. Consider the code in listing 7-8 that models the situation in which a chef fixes an incorrect order and personally brings it out to the customer. The function fix incorrect order defined in the back of house module calls the function deliver order defined in the parent module by specifying the path to deliver order starting with super. Deliver order is at the same level as this back of house module, right? So these are siblings. And you need to call deliver order from inside this function that's inside back of house. So you go back up one level, right? From inside the back of house, you go back up one level and then call deliver order. Okay, this is clear enough, I think. Relative path. How would you do this with an absolute path? Let me just copy this. Let's paste it. What if we do create deliver order? I think that's going to be the same thing. So this would be the absolute path. And super version would be the relative path deliver order. And these should compile. Let's go back. I'll go build. Right. And it compiles with just some warnings. The fix incorrect order function is in the back of house module, so we can use super to go to the parent module of back of house. Right? So at this point, from this point, you go back one level, right? Because you're inside back of house, you're at level 1, but deliver order is at level 0, in the same level as this mod back of house. So super lets you go up one level. From there, we look for deliver order and find it. Success. We think the back of house module and the deliver order function are likely to stay in the same relationship to each other and get moved together. So should we decide to reorganize the crates module tree, and get moved together, should we decide to reorganize it? Right. Okay. Therefore, we use super, so we'll have fewer places to update code in the future if this code gets moved to a different module. I wonder if VS Code has the JetBrains IDs have these move algorithms where when you change something's place in the file system, any paths to it get updated. I wonder if VS Code has something like that to help you change the order of things if you want. That would be helpful. Otherwise, you'd have to I guess find and replace. Okay, making structs and enums public. We can also use pub to designate structs and enums as public, but there are a few details extra to the usage of pub with structs and enums. If we use pub before a struct definition, we make the struct public, but the struct's fields will still be private. Right, just like classes in some languages. So you define getter and setter functions. We can make each field public or not on a case-by-case basis. In listing 7-9, we defined a public back-of-house breakfast struct with a public toast field, but a private seasonal fruit field. This models the case in a restaurant where the customer can pick the type of bread that comes with a meal, but the chef decides which fruit accompanies the meal based on what's in season and in stock. The available fruit changes quickly, so customers can't choose the fruit or even see which fruit they'll get. Okay, so that's the function. We have the public struct here, breakfast, and it's inside the module back of house. It has a public toast field, which is a string, and a private seasonal fruit field, which is also a string. And breakfast implements a method, public method here. It's called summer. Takes toast, which is a string slice, and returns breakfast. String from toast. Okay, so this is the type of bread, probably. And seasonal fruit is hard-coded, be peaches. Yes, the chef is hard-coding it here. And then they have a public function, eat at restaurant. There's a meal here, mutable, back of house, breakfast, summer, rye. Why is it mutable though? Does it have to be mutable? Order breakfast in the summer with rye toast. Okay. Change our mind about what bread would like. Right, that's why it's mutable. You're changing meal toast. They want to demonstrate this. So this toast field is public. So if you create a mutable struct, summer breakfast, summer rye. Okay. Call the function summer, and you're giving it the toast name, rye. And that function creates a mutable breakfast, which is called meal. Change our mind about what bread would like. Okay, so you say meal.toast, change that to wheat. And then you print line. I'd like blah toast, please. And print whatever's inside meal toast. Should be wheat. The next line won't compile if we uncomment it. We're not allowed to see or modify the seasonal fruit that comes with the meal. So this is not valid. Okay, that makes sense. Let's try and uncomment that and try and compile this. It says private field you can't assign to it, right? Which is expected. Can't assign to seasonal fruit because this field of the struct is not public, it's private. So you can't do meal period seasonal fruit and then assign something to it. But you can do it with toast because toast is public. Okay, cool. Because the toast field in the back of house breakfast struct is public, in eat at restaurant, we can write and read to the toast field using dot notation. Notice that we can't use the seasonal fruit field in eat at restaurant because seasonal fruit is private. Try uncommenting the line, modifying seasonal fruit field value to see what error you get. Right, we did that. The error was private field. Also note that because back-of-house breakfast has a private field, the struct needs to provide a public associated function that constructs an instance of breakfast. We've named it summer here. If breakfast didn't have such a function, we couldn't create an instance of breakfast in Eat at Restaurant because we couldn't set the value of the private seasonal fruit field in Eat at Restaurant. In contrast, if we make an enum public, all of its variants are then public. Okay, so all of these are public. We only need the pub before the enum keyword, as shown in listing 7-10. Cool. Okay, this is good to know. The difference of enums from structs. I feel like enums are more versatile in general than structs. Because we made the appetizer enum public, we can use the soup and salad variants in Eat at Restaurant. I think I would need a primer on where to use a struct and where to use an enum. The best practices of that. Probably gonna make video series on. After I actually learn Rust, I'm probably gonna have a video series teaching Rust, a Rust course. This is just me learning the language right now. Because we made the appetizer enum public, we can use the soup and salad variants in Eat at Restaurant, right? Like this. Soup and salad. Right, but we're not trying to change them anyway. Of course we can use them. I mean, it's the same as a struct. You can use the seasonal fruits, you can read from it, but you can't assign to it, right? That's the problem. I don't think this example actually covers that. Enums aren't very useful unless their variants are public. It would be annoying to have to annotate all enum variants with pub in every case. So the default for enum variants is to be public. Structs are often useful without their fields being public, so struct fields follow the general rule of everything being private by default, unless annotated with pub. There's one more situation involving pub that we haven't covered, and that is our last module, system feature, the use keyword. We'll cover use by itself first, then we'll show how to combine pub and use. Okay, so we're going to do that in the next video.